A body travels 200 centimeters in the first 2 seconds. In the first 2 seconds, and 420 centimeters in the next 4 seconds. A body travels 200 centimeters in the first 2 seconds. And 420 centimeters in the next 4 seconds. What will be the velocity at the end of the 7th second from start? Yes. What will be the velocity at the end of the 7th second from start? I take it again. A body travels 200 centimeters in the first 2 seconds. And 420 centimeters in the next 4 seconds. And 420 centimeters in the next 4 seconds. What will be the velocity at the end of the 7th second from start? What will be the velocity at the end?
Please repeat the question again.
A body travels 200 centimeters in the first 2 seconds, and 420 centimeters in the next 4 seconds. And 420 centimeters in the next 4 seconds. What will be the velocity at the end of the 7th second from start? What will be the velocity at the end of the 7th second from start? That is your take home. Okay, so you try this, send it to me. Whoever gets this right wins a traveling visa to Dubai after COVID. So work hard, okay? Work hard. Work hard. So, Zubia, today your line isn't so clear. Reposition. Reposition.
The network is poor.
Come again.
Mr. Yes, please, can I get a question again?
Okay. You don't worry. Since it's a trial work, I'll take shot of it and upload it on the platform, okay? So you could pick it from there, right?
Yes, please.
Okay. Let's use, we have about 40 minutes to go. Let's look at vertical motion under gravity. We've looked at linear motion, one-dimensional motion in a straight line. We are looking at vertical motion under gravity. And this is about when a body is projected or thrown down, up, or up, down. Okay, so when a body is thrown to go up, what happens? When a body is dropped from a height, okay, vertically downwards, what happens? This is all that vertical motion under gravity is about. Please, are we okay?
Yes, please.
Yes, please.
So let's first and foremost look at vertically upward motion. upward motion. And here we are looking at when a body is thrown. Oh, Casey, I think it will be a network problem. I'm right on the screen. I can even see myself on the screen. So if you have that challenge, please try reconnecting to see if that will be sorted out. Okay. So for vertically upward motion, we are talking about when you have a tennis ball or an object in your hand and you throw it upward. That is vertically upward motion. Downward motion, a coconut is plucked or mango, whatever. Okay, mango is plucked, okay, from its stalk and then it's dropping to the ground. That is what vertically downward motion is about. But the good news is that whether vertically upward or vertically downward, all bodies, okay, either vertically upward or downward, are affected by the force of gravity. You see, whenever an object tries to go up, the object finds itself within the line of gravity. And what is force of gravity? Class, what is force of gravity? Yes, let me pick your views on what you make of force of gravity. Gloria.
Force of gravity is the force that pulls objects towards the center of the earth.
Exactly. So long as we find ourselves on the surface of the earth, okay, we are affected by force of gravity. But force of gravity would greatly affect you when you try to move upward, or when an object is at a height and the object is thrown or is dropped to the surface of the earth, then you feel the effect of gravity better. As we walk on the surface of the earth, yes, we are affected by gravity, but we don't feel it. We can only feel it when we try to jump. So if Mr. Edria tries to jump, then gravity will bring him down. Is that okay?
Yes.
Good. So that is it. Now, so it is the force that, okay, tend to bring objects towards the center or pulls objects towards the center of the earth. And this force causes objects that finds itself within the gravitational field, okay, to accelerate with a value, a constant value known as acceleration due to gravity. So if you are thrown vertically downwards, okay, you accelerate towards the surface of the earth with an acceleration caused by gravity with a value of approximately 9.8 meters per second squared, or sometimes we approximate it to 10. And when an object is thrown vertically upward, it will also decelerate by this constant value of 9.8 meters per second squared. Okay, that is how gravity accelerates or decelerates bodies within the gravitational field. Now, on the surface of the earth, you see, this value of acceleration due to gravity actually varies on the surface of the earth from place to place, okay? But the variation is so small, or what we sometimes say as so insignificant, and so it is generally approximated that on the surface of the earth, it is acceleration due to gravity is constant. But the truth of the matter is that it varies a little from place to place, okay? From town to town, even from country to country, or even from at the latitudes of the equator, at the latitude, it varies on the surface of the earth, but the variation is so small. So we often approximate that on the surface of the earth, acceleration due to gravity is equal to 9.8 meters per second squared. Now, from planet to planet, the variation is huge. Okay. Acceleration due to gravity on the moon is equal to G on the moon is equal to 1.64 meters per second squared, whereas on the surface of the earth, it is approximated to 9.8, though there are some decimals, but 9.8 meters per second squared. And what it means is that on the moon, objects would weigh less because our weight is equal to mass times acceleration, the pull of gravity on us. So if on the moon, acceleration due to gravity is 1.64, then objects, Mr. Abia will weigh less on the moon. Okay. I'll weigh less on the moon and weigh more on the surface of the earth. So, yes, that is it with how objects are accelerated, okay, and decelerated by the force of gravity. The value is approximated to be a constant value of this on the surface of the earth. Then this value of gravity also varies with height. With height, meaning the more we go, the higher we go, the lesser this effect of gravity on us. Please, are we okay?
Yes, please.
So G is inversely proportional to height. It is even a square of the height, meaning the higher we go, the lesser the value of acceleration due to gravity. Okay, but once we find ourselves on the surface of the earth, we approximate it to be a constant value. Please, any question? Any question? Okay, so let's look at vertically upward motion. Before an object could go up, a force must be applied on the object. Because, yes, as I have the duster in my hand, all right, the duster by itself cannot go up. Before it could leave my hand and then go up, I have to apply a force. As you apply a force, you give the duster a certain initial velocity. The force gives it an initial velocity. But as the duster moves up or goes up, you realize that its force or its velocity will be what? Reducing. Will be reducing gradually. That is why the duster, when thrown, could go a certain height vertically and cannot go again and will have to come back to the surface of the earth. What it means is that as the force is applied, the force gives it an initial velocity. As the body moves on and on, this initial velocity is reduced. There comes a point where the initial velocity given is reduced completely to zero. When the initial velocity is reduced to zero, then the body cannot go up again. It means it has covered its maximum distance and will have to come back to the earth. Okay. And as the object goes up and its velocity reducing, do we say the body is accelerating or decelerating?
Could you repeat the question again?
If the body is given an initial velocity by the force applied, then as it goes, This velocity given is reducing, okay, gradually reducing to a point where it has completely been reduced to zero. Do we then say that as the body goes up, it is accelerating or decelerating?
Decelerating.
Decelerating. And this deceleration is caused by who?
The force of gravity.
Is caused by the force of gravity. Good. So when bodies are thrown vertically upwards, the body decelerates. Due to gravity. Okay, it decelerates due to gravity. Okay, because of this, in fact, we can have or we can derive equations of motion for bodies moving vertically upwards. So let's look at equations of motion for vertically upward motion. These equations derived for vertically upwards and downward motion is also similar to the equations of linear motion we've studied. You see, in linear motion, the first one, V is equal to U plus AT. So for linear, for vertically upward motion, the first equation becomes V is equal to U. Now, here we are considering the body to be accelerating. And when the body is thrown vertically upwards, it decelerates. And this deceleration is what? Negative. And this deceleration is caused by gravity. So A changes to be minus JT. Minus because the deceleration is due to gravity. So it changes, okay, from A to G to signify that, yes, the deceleration is due to gravity. Please, are we okay?
Yes, please.
Yes,
And-
please.
And because it's a deceleration, that's why we have minus here. So the plus changes to be minus because this is a deceleration. Second equation of linear motion. We have S is equal to UT plus half AT squared. When it comes to vertically upward motion, the equation becomes S is equal to UT, because A here changes to G and it's a deceleration, we have minus half JT squared. Okay. I want us to guess how the third equation will look like. How do you think the third equation will look like? Yes.
Where
Amma, go ahead. You go ahead.
E squared
V
is equal
squared.
to U squared minus 2G.
Minus 2JS. Very good. So these are the equations used when it comes to vertically upward motion. Vertically upward motion. All right. Now let's play around this and then learn about some standard equations or formula. Standard equations for vertically upward motion. You see, when an object is thrown vertically upwards, we just learned that the object will decelerate due to the effect of force of gravity. And because of the deceleration, as the object's journey on upwardly, this velocity, initial velocity given, would reduce or will be reducing. It will reduce to a point where the final velocity will be brought to zero. When the final velocity is brought to zero, the body has reached its maximum height, meaning that is the extent I can go. So the maximum height is reached when the final velocity of the body is equal to zero. So please take note that maximum height reached goes with a final velocity of zero. Are we okay? Are we okay?
Yes, please.
So if I throw an object from the surface of the earth, then it could go this height. There's the object. This is the maximum height the object can go. So I said this is max height. At the maximum height, the final velocity of the body must be equal to what? The final velocity of the body must be equal to
Zero.
zero. But the initial velocity must be a larger value because that is certainly what will project the object to go up. So using this equation, or even equation 1, using equation 1, of vertically upward motion, we can derive a standard formula for the time taken by the object to reach the maximum height. Okay, how do we do that? Using equation 1, which is V is equal to U minus JT. We know that when the body gets to the maximum height, at maximum height, final velocity is equal to zero. So if at the maximum height, final velocity is equal to zero, then this equation becomes 0 is equal to U minus JT. Okay, Gloria, help me make T the subject. We want to make T the subject from this relation.
Mr. Abia, please, T will be equal to U over G.
So T will be equal to U on J. All that it means is that when an object is thrown vertically upwards, and I'm asked to calculate for the time taken to reach the maximum height, what I am calling as T max. T max is equal to the initial velocity divided by gravity, and I have it. So that is one of the standard formula under vertically upward motion. Please, are we okay? Are we fine?
Yes.
Yes, please. Yes, please.
Amma, go ahead.
So T max stands for
Okay. Where T max is equal to time taken to reach the maximum height. Okay, so I've defined what I use as T max. Is the time taken to reach the maximum height. Then, hello.
So please, this T-max is used when you are asked to find the time taken to reach the maximum time.
Exactly. So, meaning if you are asked to calculate for the time taken to reach the maximum height, it's just the initial velocity divided by acceleration due to gravity, and you are there.
Yes, please.
Another standard equation. We are still on the standard. Can I go in the middle part of the board?
Yes, please.
Okay, so what is also the equation for the maximum height? We can also deduce a simple equation or formula for determining the maximum height reached. Whenever we are asked to calculate for the maximum height reached, okay, and what we have at the back of our mind is that maximum height reached, maximum height goes with what?
Maximum time.
Maximum
time.
Yes, maximum time, and the condition for attaining the maximum time and maximum height is that
Final
the
velocity
is zero. Good. So if at the maximum height v is zero, then using v squared is equal to u squared minus 2as. We can get an expression for s, because at the maximum height, this is zero. So 0 is equal to u squared minus 2, j, not a, js. Then we make s the subject. Yeah, somebody to help me. Then we make s the subject. Akosia.
and S is equal to U squared out of 2G.
Go. So if you bring this term to the left-hand side, you have 2js is equal to u squared. Therefore, when you divide through by this, you have this, s is equal to u squared on 2j. Now, because for vertically upward and downward motion, we are talking about height. We want to change our variables small. Instead of s, we want to use h. All that we are saying is that from the point of throw of the object to where it will reach is the height, maximum height h. And so h max, subscript max, is what we are using for the maximum height reached. So where h max equals maximum height reached. Are we okay? Are we fine?
Yes, please.
Yes.
Hello.
Please, because you use C max for the first one, can you use X max for this one?
Oh, yes. I'm only using H because height. You see, the S is a linear motion is used to represent displacement.
Yes.
Okay. Please, I'm coming in. Let me pick this call and get back to you. All right. So we are using S for displacement. So under vertically upward and downward motion, because we are looking at vertical height, that's why I'm changing it to H. But it isn't any new thing, right?
Yes, please.
Okay, another way of extracting the same equation or relation is this. You see, when you use the second equation of motion, which is S is equal to U T minus half JT squared. Okay, and here we are changing our S to H because we are talking about maximum height reached. We got an expression for the time taken to reach the maximum height. So T is equal to U on J, correct? So let's substitute what we have for T into all the T's we have in, okay, the third equation. So we have U times U on J minus half J times U on J all squared. Please, I hope you are not confused. Are
No,
you?
please.
Good. We still want to derive the same equation by using a different approach. And here we are using the second equation of motion, which is this. So substitute the formula for the time taken to reach the maximum height, which is this, into the equation. When you do that, we have this times this U squared on J minus half J. This is U squared on J squared. Okay. Then we have U squared on J minus half. You see, this is a numerator of J. This is also J squared. J squared, please, is the same as J times J. So this J would cancel one of it. So we could have U squared over J. So U squared on J here. Are we okay? Are we fine?
Yes, please.
All right. So that H becomes U squared on J minus half J on U squared. And we can factorize out U squared on J. So U squared on J out, we have 1 minus half. And class, what is 1 minus half? What is 1 minus half?
Half.
Half.
Good. So we have u squared on j times half, giving us the same expression as u squared on 2j. Okay, the same H-max equation. So we could also use this relation, the second equation of vertically upward motion, to derive the same expression for H-max, the time taken to reach the maximum height. You appreciate it better when we start solving questions. Okay, I'll use this one, and then you get the difference so better or so well. Are we fine?
Yes, please.
A quick
Yeah.
a quick probing of your understanding. I want to do this. A body was projected vertically upward from the ground and then got here. So this is the maximum height. If it took a time of t is equal to u over j to get to the maximum height, what time will it take to return back to the ground? It takes to return back to the ground. Yes, plus. So if it takes a time t is equal to u over j to get to the maximum height, what time will it take to return back to the ground? Yes. Anybody to share? Agosia.
The same u over j.
So what? So t, let's take this time to be t. Okay, so what will be the total time of flight? What will be the time of flight?
2u over j.
2u.
Over
So 2u over j. Okay, so Akosia, what is time of flight?
2 times the first.
No, I'm asking, how will you define time of flight?
Okay, time of flight is the total time taken to move up, and time of flight is the total time taken, which is the time taken to move up and the time taken to move down.
Okay, so class, time of flight simply means that the total time taken during the whole journey of the object from the point of its throw or projection to the point of